good afternoon to everyone that's joining us. And welcome to today's webinar, where we're going to explore AI-powered bit grading with our integration partners, Zerdalab. So my name's Jay McClelland. I'm Innova's technical manager, and I am delighted to be joined by Vasily Zabriskie, Zerdalab's Chief Technology Officer. So thank you for joining us today, Vasily.
Thank you.
I will start by saying that this webinar is being recorded, and the recording will be available on both companies' websites by tomorrow. So today we are going to be discussing AI-powered bit grading, which is aimed at simplifying and improving the consistency of the way that we grade bits across the industry. We're going to begin with a brief introduction to both companies and their respective roles in the industry, followed by an introduction and a demo of the integration itself. We'll then finish with a Q&A session. So if you have any questions as we go along, please add these to the Q&A section available at the bottom of your screen, and we will do our best to address these at the end. So for those of you that are unfamiliar with Innova, we are a technology company that's developed a suite of industry-leading software solutions tailored to the energy sector's needs. Our software primarily focuses on three key areas. We've got directional drilling, well planning, and drilling engineering. And one of our primary goals is to offer solutions that enhance data flow and simplify complex manual processes. So to achieve this and meet the industry's consistently evolving needs, we've introduced cutting-edge software solutions along with API integrations. These innovations enable cross-platform communication and data transfer, providing our clients with a more streamlined and efficient workflow. Now, our API capabilities not only enhance data accessibility, but also fosters collaboration with like-minded companies such as Zerdalab. And together, we've created an integrated solution where users can utilize Zerdalab's advanced AI bit grading functionality directly in our web portal. So as most of you are likely aware, bit grading is something that anyone can do with some basic training, but it is a very subjective measurement. How a bit's graded can be affected by lots of factors, and if you give 10 different people the same bit to grade, it's unlikely you're going to get the same grade back from all of them. But bit grading is a crucial aspect of drilling operations, as it provides valuable insight into the efficiency and performance of a drill bit. And the information gathered can be used to optimize drilling practices, select appropriate drill bits for specific formations, and enhance overall well planning for offset wells. Our integration with Zerdalab utilizes advanced machine learning to make the bit grading process more objective and therefore consistent. And it's as simple as taking a picture of each blade of your PDC bit and loading them onto the web portal. All the user needs to be able to do is take a clear picture with their phone or a camera. So as we progress through today's webinar, we'll explore this integration in more detail and highlight the tangible benefits it offers to the industry. I am now going to pass you over to Vasily to let him introduce himself and Zerdalab.
Thank you, Jay. So yeah, as Jay mentioned, I'm a CTO and a co-founder of a company called Zerdalab. We are a young startup focusing on PDC drill bits design and development and streamlining of bit selection process for best possible performance, ultimately. And when it comes to dull grading, it is an instrumental part of understanding the bit performance. It helps to assess the bit design success, but also the selection strategy for your application against various performance objectives, such interval, ROP, directional, or combination of all of them. And to do that, you have to be understanding the condition of the bit in relation to the performance of the drill bit. Collecting this information helps to ensure that continuous improvement process is always in place. You have to know if you're actually doing better or worse, if you're meeting your objectives, if there is an opportunity to push for a little bit more from the design perspective, or from the way you're using the drill bit. So, and this knowledge then can be analyzed and applied either within the field, for continuous development of the field, or knowledge can be generally shared for, let's say, similar lithologies or similar type of BHA, similar kind of ways of drilling and failing the rock. More importantly, it helps to understand what not to do as well when the bits actually fail abnormally or prematurely. So that's why it's important to collect this information. So you can then learn the lessons and correlate the condition of the bit that you see versus the design intent. So DAL condition assessment process and reporting is advised by ATC DAL grading guidelines, which provides rules and codes and instructions on this particular subject. They're quite set, quite robust. The current main method, although of DAL grading the drill bit, is highly manual. So it's an engineer who is pretty much visually assessing the drill bit and following those rules and regulations comes up with the assessment of the drill bit. This methodology presents various shortcomings, such, it can be quite time consuming. So if you want to do it right and you want to do it cutter by cutter and document the entirety of the cutting structure, it can be time consuming. It is subjective to the assessor experience and expertise. So obviously the guidelines are quite clear, but the experience level might differ between people who are assessing the drill bit. But it's not also the way you evaluate the drill bit can differ from person to person, but also your interpretation of the ATC DAL grade guidelines, right? So and it's quite common actually. And as you said, the consistency is not there, and you give a DAL grade to various people, you get a slightly different flavor of the assessment with justification, obviously. So, so for us at Zerdalab, the company that is designing fit-for-purpose, fit-for-application drill bits and develops various models and algorithms for automated bit selection, the quality and speed of the DAL grading is equally important. It's considered equally important part of the process, because we need to understand if that selection actually worked, if that set of design decisions translated to what we expect to see at the end. So, when you think about such a structured but repetitive task of DAL grading, like what is the better way of dealing with that than machine learning? In fact, machine learning is actually designed for this highly repetitive routine tasks with a really rigid set of rules. So, and it frees up an engineer, instead of doing this quite boring, actually, part of exercise, very important, but quite boring, to actually do what engineers are supposed to do. Engineers are supposed to be solving problems and finding solutions, not counting cutters, right? So, so we spent last 2 years building and training a testing model based on countless number of bit photos available in the public domain, and we've used historical data, all sort of different quality of the pictures right through the years, of all sorts of different drill bits to train the model and to make it as robust as possible. So, and we moved to the point when we were ready to push for public beta testing, and we've developed the user interface through the app, so that's standalone to the user. But when it comes to scaling up this and giving it to a lot of people, I mean, I couldn't, like, partnership with Innova Drilling is almost like, the ideal symbiosis of two software platforms for this, because you're already in the business of collecting a lot of engineering data, and actually manually collecting DAL grading data as well, right? So, and when we had the first meeting with Innova Drilling, they were very quick to identify the opportunity and the potential of this. And as far as I know, Innova Drilling is the first company who's doing it that way, integrating the DAL grading on the back end. So, and I think the best way to actually to wrap my part of conversation is to actually to go to a demo and just show how it actually works.
Yeah, that's perfect. Thank you, Vasily. I will share my screen so that we can go ahead with the demo. Perfect. So we'll start and we'll take a look at the demo now. And the demo has to start with basically a picture of the bit, because that is where it all rests. At the end of the day, the bit comes out of the hole. We need to take pictures of this, and they need to be clear pictures of the cutter face of each of the blades of your PDC bit. And we also need a picture of the top as well. So here's an example of the kind of thing that that we're looking for. And in this day and age, with the resolution and the types of cameras that we have available, it should be fairly straightforward to be able to take a clear picture of a bit. But just sort of, for everybody's information, Vasily, if we have any pictures in here that are not as great a quality, how does that affect the output? Can you still give us an output with a picture that's maybe not quite as clear as you would like it to be?
So as I've mentioned, we've used some historical data, a lot of historical data from a public domain, and the quality of the pictures varies a lot. So we're using a lot of various different techniques to improve cutter detection. So ultimately, what we're trying to achieve here is to find each cutter and to remove anything that looks like a cutter, but shouldn't be included into a dull gray. So and yeah, so the detection is quite good, even if you have a kind of highly oversaturated or overexposed picture. But generally, if you can assess the dull grade yourself from the picture, then the software will be able to do it. If you don't see some cutters yourself on the picture, so the software obviously would not see those cutters as well. Likely will not to see those cutters. But yeah, it is quite robust, and we get quite a good success rate even with poorer quality of the pictures.
Okay, well, that's good to know, because yeah, I mean, basically, if you can look at the picture and you can determine the dull grade from it, then the computer is going to be able to do that at the same time as well. So with our pictures, we can then load these up onto our portal. Now, if we're going to be doing the demonstration in the portal, but if you do have the app, which you can download onto your mobile phone, you would be able to take the pictures directly on there, and they would be loaded directly from there. So that's another way for you to upload them. But in our case, we access our portal, and our loading page of the portal is all the active jobs that we have, and associated with those is all the rest of the data that we are storing. And in our case, we're interested in the drill strings specifically. And just wait for this to load. In this particular example, we've got 5 BHAs in here, and then for each BHA, we have got all of the various components, and the one that we're interested in at the moment is our bit. And for each of our bits, we've got a grayed out section. Now, at the moment, anybody that does not have this sort of integration, it's just a simple case of you would come in and select from drop-down menus in the same way that you've always done. But with the integration, we can come along and we can add our BHA images in here. So it's very simple. You can select multiple, you can select individuals. And in this particular section, this is not just for bits. This is for anything else that you want to put in there that's relevant for your reports. So in our case, we've uploaded the bits that I was showing you earlier on. And the way that we determine these, or we differentiate these from everything else as being drill bits, is just by selecting this little checkbox in here. And once you have those selected, the option to grade the bit down the bottom will be available. And it's just a very simple process of hitting grade the bit. Now, at this point, what will happen is that the bit pictures, and only the bit pictures, will be getting sent across. Now, there's a lot of information potentially associated with the bit that we store within our databases, and we'll talk about that closer to the end. But at the moment, this bit via the API is winging its way across to Zerdalab. So, Vasily, could you kind of explain a little bit about what's happening on the Zerdalab end when you receive these pictures?
So we receive the pictures, obviously, and we put it through various models to extract the dull grade in the approved format by current ADC guidelines. So first of all we detect cutters and extract grade from those cutters, i.e., we count volume of diamond that is being lost, and then we apply semantic segmentation model on the cutter to determine the character of the damage. Is it broken? Is it worn? Is it chipped? And etc. Well, we look for all sorts of anomalies and also run a separate model that helps us to make sure we focus on the blade in question. So we actually determine the shape of the blade, i.e., this is the blade in question, because as you can see from the picture in the example, there are some other cutters on other blades in focus. So that was probably one of the most difficult parts to ensure that the other cutters from other blades are not part of the assessment. Also things like nozzles, right? They also like little circles. From the software perspective, again, another trick to determine that this is not a cutter. So we combine the results and return ADC dull grade back to you. And that's pretty much all that happens there. We do not see any metadata associated with this. We have a sequential ID number of the computation. We do not know who is doing it. We don't know for what well, for what run, for what BHA whatsoever. All we see is those big pictures, and we do the computations and send you the results back into your system.
Perfect. Thank you for that explanation. So yeah, so we can see that, you know, it doesn't take very long. It fires us back our bit grade, and we can see that there's a couple of options here that are highlighted in orange, and these are options that as a user you have to manually select. So we've got to choose the reason pulled out of whole, and we've also got the gauge in here. Now the gauge is something again that the user has to select manually. So in this instance, Vasily, can you kind of explain a little bit about why this comes back? You know, why is this something that the user's got to select?
So there are a couple of things that. So there are two aspects to any dull grade. One is visual inspection of a certain condition, like, you know, condition of cutters and etc. And some other aspects that on the bits that either need to be tested or measured. So the one tested, a good example is the seal on the roller cone, right? So you're supposed to actually test physically if the seal is intact. The same with the gauge. So gauge of the bit is considered to be a critical dimension of a drill bit. And the difference between go gauge and no-go gauge is so minute you cannot really eyeball it. So if you cannot detect it by eye, it's very difficult to do it by the machine learning. So the resolution is not there, but it doesn't have to be we think, because this measurement is critical and it has to be measured physically. Even if I tell you that, you know, we've applied, you know, LiDAR and all sorts of trickery to determine this, you still would want to measure it. So it's one of those measurements that has to be physically performed.
Okay, well that makes sense. So, and you can see it's clearly highlighted in here as something that needs attention. And obviously, in addition to the bit grade, we've also got some really useful information here in terms of any potential dysfunctions and recommendations to you know, to address this in the future. So again, can you explain a little bit about this and where this comes from?
This is a separate model that is adjacent to our core model on assessing dull grade. So we determine, to be able to determine to come up with the dull grade, you have to zone the bit and know the distance from cutter to cutter and where the cutters are. So that helps you to identify certain patterns on the drill bit. And those patterns usually associated with certain dysfunctions, and the ones that are obvious, we actually hard-coded them into this model. So it pretty much gives an engineer some pointers of how to actually look at this bit condition and how to interpret this. Again, it's an expert-based model. It's how an engineer would look at this and describe this condition. So we think it can be quite powerful, especially if downgrading the bit is not your primary thing. Some engineers, they do 1 or 2 downgradings a year. It's very difficult to retain all this information. So this gives you a pointers on how to talk about this condition to your vendor and what to write in your reports as well.
Yeah, absolutely. I mean, like you said, I mean, within a company, there may only be 1 or 2 people that would delve as deep to get this information, and they've got to work to do that as well. Whereas this is information's available to anybody that's run the calculation. So, yeah, really useful extra information. So in this situation now, when we're happy with the bit grade that we've got, we just hit accept. And once we hit accept, it pulls the grade directly in to our BHA for us. And this is something to point out, is that if a user has got a strongly disagrees with this for any reason, then they do have the ability. This is not something that's fixed that then cannot be adjusted. It can be adjusted if there is a justification for it. So it is something that that could be edited if required. Now, and that's pretty much as simple. That's as simple as it is. It's the pictures, 1 for each of the blades and 1 for the top, and then you either pull it in via the app or you pull it in via the portal. You assign it to your BHA, and then you run the calculation, and then you can pull it in. And we mentioned earlier that the data that gets sent across to Zerdalab is literally the pictures. There's nothing else goes with it. But if you think about the information and the metadata that we have got associated in the Innova portal, I mean, you have a bit which is associated with a BHA. That BHA is associated with a well and has done, it's been in the hole, it's drilled through certain formations, it's got certain ROPs, it's got all the parameters that were used associated with it, it's got the surface locations in there. There's lots and lots of information within our system that can be associated with that drill bit. Now, if the correct permissions were in place, Vasily, and when we pushed those pictures back to you, it contained all of that information. I mean, where could this go? Where's the potential for this to go in the future with all that data, and how could that sort of help the industry as a whole?
Yeah, that's a good question. Obviously, it opens up an opportunity to do all sort of offset analysis, all sort of statistical analysis, automate all sort of visuals that help you to understand the generally field performance of your drill bits, compare performances between the drill bits, have a top performing bit in this rock, in this particular lithology, straight away, like a ranking system, but also transfer this knowledge to some other similar fields. Generally, the fact that it's all centralized in one place allows various engineers within the same company to actually to come up with all sort of opportunities to share this knowledge. Generally is focusing around statistical analysis and offset analysis that can be actually almost automated and done on the go, to create all sorts of performance summaries, to give you pointers straight away on what bit to use next time in a similar field, without mining through a lot of data and reading a lot of end of the well reports, which is obviously a summary of what you've done in a previous well. So yeah, it is very powerful when the data is accurate and consistently collected in a central location, and there is a consistency between the measurements as well. Yeah, it's very powerful.
No, that's great. And actually something that you touched on when we were speaking about this previously was the fact that, you know, in the situation where you are taking good pictures of your drill bit and you're associating those with your BHAs, and those are then in the system and they could be in the system forever. If anything changes with the way that you know the grading recommendations go, you know, over the years, the potential's there to go back and retrospectively, you know, effectively regrade those drill bits as a result of it, because the information's there.
Absolutely, absolutely. So currently, the information, when it's collected manually, is stored in one line code, usually in the database. Various kind of databases, various complexity databases. Some of them include pictures, some of them don't include pictures, but generally the ADC dull grading system is evolving because ultimately it tries to achieve the state where it gives you a mental picture of a drill bit by just looking at the grade. And there are various methodologies of actually doing it, and I'm sure it will evolve over time. The good thing about collecting data in this way and that centralized, you can retrospectively change you can retrospectively change the way the final line of the grade is actually calculated. Let's say they're changing zoning rules, for example, or at some point secondary cutters will start becoming a part of the assessment or a separate assessment as well, right? So all of this can be done.
Yeah, no, that's perfect. Okay, so I think from my perspective, you know, that's a quick demo of the soft, you know, of this particular integration. We've got a few questions, so I'm going to stop sharing my screen at the moment, and we're going to take a quick look at some of these, Vasily, and hopefully we can answer some people's questions. So we've got one here from Eric Robles, and it says, if a cutter is missing, does it determine that the cutter is missing, or does it not see any damage to cutters?
We detect lost cutters. Lost cutters, yeah. So if there is a clean pocket, it will know there's supposed to be a cutter, and it looks like a clean pocket.
Okay, so that is something that it will see, and it factors that then into the grade.
Yeah.
Excellent. Right, let's see if I can find another one. 2 seconds. So we've got one. How does a system consider a spalled cutter? Is it graded as a completely gone 8/8 dull, or is it graded based on the flat wear of the cutter? And that's from Enes Aliko.
That's a good question. So when you know it's physically still the same size, right? So it's still a circle from the software perspective, but it's spalled. So we use semantic segmentation to determine diamond loss, and you know, judgment is based on that. So if semantic segmentation tells us that the cutter is spalled, no matter how much of this is left, it's considered as it is, you know, damaged.
Okay.
So that's the power of semantic segmentation, because few things can look like, you know, the cutter is intact. This is particular question here, but now you need to drill into the actual nuances of that particular picture to determine the finish, right? So, and semantic segmentation will allow us to determine spalled cutter.
Right, now I can see we've actually, I should have probably mentioned this as well. So we've got Rana Ahmad, who's also one of the co-founders. He's been sitting in the background looking at some of these answers, and he has provided some while we have been in here. So one of the questions was how to, and this was from Anonymous, how to grade hybrid bit as like a chimera bit.
Okay.
So, and Rana has come back with this, and he just says that the system will basically grade the PDC bit section of it, and not the roller cone side of things.
If I'm not wrong, you know, if we're talking about Chimera specifically, or you know, roller cone with PDC type of bits, you usually provide 2 lines of dial grade, one for roller cone and one for PDC. In fact, roller cone code's actually different to PDC, so you have to grade them differently. You still can use the app to grade the PDC part. Yeah, the app is currently focusing specifically on the PDC drill bits. Talking about future development, of course, things like other bit types can be considered, though the vast majority of drill bits that are in use today is actually PDC bits, and these proportions are actually growing.
Okay, perfect. What have we got here? Let's have a look. So we've got another one here. What about damage to the backside of the cutters, maybe due to backward whirl? And we've, yeah,
so ultimately the dial grading is about the primary dial grading is about the diamond loss. So if you lost the diamond as the result of the damage to substrate through backwards whirl. Also, if you're on backwards whirl, you probably will damage the secondary components there first. I don't know if you refer to this one. Secondary components are not part of a dial grade, so they actually excluded. We actually do a lot of work to exclude them and focus on the primary cutting structure.
Let me see, what else have we got?
That's a good question. Yeah, those are the questions. Like, those are the questions actually people asking themselves when they attempt to downgrade the bit. You know, how do I look at this? What do I do with this? You know, and that's why I've mentioned that the ADC guidelines themselves, there's still a deviation in how it is interpreted among the community. So, and the systems like this allow us to kind of to bring it to common denominator and to follow the guideline as it is written.
Okay, thank you. So one of the other ones is, will it detect shaped cutters?
Yes. So again, as I said, we historically used a lot of photos of various drill bits, including shaped cutters. So yeah, it detects shaped cutters, and it looks to it measures the longest diameter on the whole shape to determine the size and calculate the volume loss. So yeah, in fact, in Zerdalab, we are very big fans of actually shaped cutters. So we needed to make sure it works with shaped cutters as well, right?
Good. Right. Next question. Can it detect tungsten carbide insert? So if there are damage to the TCI, it doesn't include it as a dull outer damage.
Yes, correct. Yeah. So that's the thing. We try to exclude anything that is not a PDC primary cutter. So that's the whole separate model on the back end is actually just focusing on things that are not PDCs, that just to make sure to mark them and not to use them in the overall dial condition assessment.
Okay. Right. Sorry, there's just a few different screens here trying to find one. Okay, so we've got one here that says, how accurate is your model?
Ooh.
This is anonymous.
All right. So define accuracy, right? So now, if you take the picture of a drill bit and you run it through the model 10 times, you get the same result, right? So 100% accurate, the same picture. So now, if you start playing with the camera and take slightly different perspective and etc., obscuring cutters, the accuracy of that drops, but only in those cases where the dial is kind of borderline between. So let's say if it's 1.4, it will round it to 1. If it's 1.5, it will round it to 2. So if you're within 10% that variation, you can end up with 1 or 2 depending on the angle. So there is a certain error. we would be able to report back on this. And actually, you know, if you want a detailed cutter by cutter calculation to see how that it is actually done, I'm pretty sure your customers can get to Innova and request this information. We can supply the exact how this number actually came about. But yeah, on the border cases where, you know, it's not exactly two, but it's definitely more than one, and you look through various different pictures at different angle, and yeah, it can skew towards one or another. So but it is quite accurate. So, and obviously, so what we do with the data that comes from you, so with the pictures, we obviously use the calculation that we've just performed to calibrate our model further. So that's the only information we actually use from you. It's added into our model, and we keep calibrating the model, and more accurate it becomes, you know, over time. More pictures we have on the back end.
Yeah, so machine learning, the more this is used, the more pictures you have, the more that you've got to draw from
Yeah.
that perspective. That makes sense. So we've got another anonymous one saying, can the system detect lost nozzles as shown in those pictures?
Lost nozzles?
Yes.
Yeah, on the pictures, those were removed nozzles, so pictures were taken after the nozzles were taken out, I guess. But yeah, it detects nozzle as non-cutter. Obviously, it will see this as a circle. So we're working on a completely separate project to this, actually, to determine the rest of the state of the drill bit. In fact, we're developing a project. We work with University of Bath on this particular issue, on the bit body assessment, so taking it beyond the cutting structure. But the downgrading is actually on focusing on the PDC components themselves. We will determine it's a nozzle, and we'll say to the software, then we'll say, okay, do not use that as do not class it as a cutter.
So basically it focuses on the fact that it doesn't necessarily determine that it's a lost nozzle, it just determines it's not a cutter, and therefore kind of ignores it.
Yeah, but separately, yeah, that's the beauty of the machine learning, and, you know, deriving computer vision parts of it, deriving certain things. You can train the model to know the difference between nozzle being in place and nozzle not being there, using semantic segmentation. That can be trained, and that's a part of a separate project that we are developing. Innova Drilling is more than welcome to use that as well once it's ready.
Right, one more that we've got here. This is an interesting one. So, can you recreate a bit design from the pictures that you receive?
No, that's impossible from the pictures that you receive. So first of all, every photo is taken at a perspective, right? So the design of a drill bit is a very precise construct, right? To actually recreate the design. So the resolution is not there. The perspective correction, we don't do perspective correction. There is no provision for us to even try to attempt to calculate things like tip profile or back rake of the cutters. To be honest, it would be quite pointless from that particular exercise to try to do it. So yeah, the technology is not there to be able to do this. We are not scanning the drill bit, by the way, right? We're taking static pictures from a very random perspective, because, you know, you literally just point the camera from where you are and you take a picture. So
perfect. And I think we've got one more in here, which just basically says, could we get a presentation or PDF in PowerPoint format so we can learn in more detail?
absolutely. Yeah, we can obviously collaborate with Innova Drilling to have the integration part, or if you want a little bit more details on what is happening, you know, on a back end. Also, please feel free to get in touch with any of us at Zerdalab. We actually currently running extended public beta testing. So if you're interested, give us a shout. You know, we'll give you some special access to some very special software for you to play with. Yeah.
Perfect. And I think the last question that we've got in here, and we are a bit over time, so thanks everybody for sort of hanging on. And like I said, we will make this available on our websites, this recording of this tomorrow, so you will be able to go back if you've got to leave and you've missed some of this. This question has been answered by Rana, and it was, can the system detect damage to the body? That's Eric Robles again, not only the cutters.
Well, again, I think it's in line to the question about lost nozzle. So this is obviously part of the body construct, which is not part of the ATC dull grade focus, which is primary cutting structure. But yeah, that's a separate project that we're working on to determine bit repairability from the picture. We actually published a paper on this one. Well, the university published their findings. So the fundamentals are already there. It's obviously a question of resources to do that. This is in our scope of work to actually develop an assessment of other features on a drill bit. Because currently what we do, we detect them and we just say, okay, ignore it. Like there is a feature, there is an artifact of sort that might look like a cutter, but it's not a cutter, right? So the same goes with, cracks detection and etc. And it's much more complex, actually, in fact, because there are all sorts of, a tiny streak of mud somewhere on the blade might look like a crack. And then obviously there is a question about matrix versus steel. They fail differently. The characteristics of materials are very different. So it is possible. Machine learning is for this kind of things, but we don't have a product yet. We have a framework for developing it, and Bath University was very helpful in giving us bright students to work on this. Yeah.
Good. And I think this is possibly the last question, although I'll check in a second. But what happens if there is a broken blade? Does the system recognize it? And this is another anonymous.
Yeah, so if you say we want 6 pictures of blades because there are 6 blades, right? So you take a picture and there is no cutter on that picture, it will just assume it's 8, i.e. the blade is not there. Because if it's just clean pocket, it would detect it as a clean pocket. So that's the beauty of semantic segmentation. Yeah. So that would be a broken blade situation. So that's it, technically a bit body damage, but it's a very special case because it's in relation to the cutters. There are other very interesting situations like ring outs and etc. So we're developing some interesting workarounds to detect an onset of ring out or full-on blown ring out and so on and so forth. So yeah.
Perfect. Well, I think we are now getting to the point where we're about 15 minutes over time. I think we've gone through pretty much all of the questions. Some of the questions were quite similar to each other, so we've just gone with. I've not read through every single one. I think from our perspective, hopefully everybody found this to be interesting, and we would be more than happy, if you're a client, if you're not a client, but you're interested in this, if you want to get in touch, we'd be very happy to give you access to this, let you have a play about with it, even if you just want to send some bit pictures through and we can run it through the system and grade them for you and send them back. So we'd be more than happy to speak to you about it. So please feel free to reach out. All our contact details will be available. They'll be sent out after this, and they're available on our website as well. Vasily, thank you very much for joining us.
Thank you for having me. Yeah.
And yeah, we'll stay tuned, and we'll be back with another Innova Academy soon. Thank you very much.
Cheers.
Bye-bye.